Unchain my heart. Okay, it would have been nice to have the music. Unchain my heart. Okay, but I will sing you another song later on. Even though, well, like Dylan, when I was younger, teenager, my dream was to be a songwriter one day. Instead, I ended up as a code writer. Yeah. This is DotNext 2017, and yesterday I had a talk titled "I Have Microservices and I Didn't Know." And the purpose of this closing session is to take you all together to a different time, 30 years from now. So we push the button like a time machine, and we'll move to a different time. Going to DotNext, welcome to DotNext 2048. My talk was, I once had microservices, but I can't remember. Sorry about that. So what is the program for DotNext 2048? This is what this session, this talk, this chat will try to figure out. What is new in 2048? Let's start from the past. What was hot in 2017? Buzzwords were artificial intelligence. 30 years ago, artificial intelligence was all the rage. Machine learning, that was a key topic. IoT, the possibility that your fridge sends an email to tell you, hey, dude, buy some eggs. And big data. And the game was who has the biggest data. That was the story. That was what was hot in 2017. And what was actually, well, the symbol there, the hard code symbol, well, it's equivocal to me, Italian, because it's the symbol that you show, it's the finger, essentially, that you show to the driver next to you when you're driving. And, well, it's not just the finger, because the finger would be between me and you. But that symbol in Italy means that your significant other, wife or husband, is cheating you. So, this is hardcore. Okay, what was hardcore in 2017? Keywords like debugging, profiling, optimization, throttling. That was an entire panel of speakers only 30 years and a few moments ago to discuss how to optimize applications. And it was nice to hear from the bios of those speakers. I've been optimizing code for 10 years. And you're still there? Are you still optimizing code after 10 years? Bus, DevOps, memory, Docker, reactive scalability, all keywords, hard code keywords in 2017. Debugging and profiling applications used to be a cool thing in 17. And in fact, we also had Sasha presenting debugging and profiling with great success. .NET Core applications on Linux. Also, serverless computing used to be a cool thing in 17. And we had here at .NET 17, Alex Thyssen presenting serverless computing with .NET-based Azure functions. Developer-less computing is now common 30 years later. And maybe even more in the future, customer-less computing. Who knows? Developer-less computing today, welcome to 2048, is now common, and we still have Alex Thyssen here presenting at DotNext, well, not exactly the same person, but presenting at the conference. Developer-less computing with .NET-based Azure robots. How did it happen? Let me tell you a story. Now, in 2008, a guy, well, we actually don't know if this guy really exists, but a name and a person behind this name Satoshi Nakamoto created Bitcoin. Bitcoin is a digital asset that uses smart cryptography to secure transactions, and that's a nice thing, to create new units of this digital asset. It's known to be, born to be a decentralized currency, opposed to classic centralized currencies which are controlled by government and corporate boards. It's the people, it's the community that controls, it's a controlled community that controls Bitcoin. But how? Why Bitcoin is so relevant in the transition in the next 30 years, in the 30 years that elapsed between 17 and 48. Oh, by the way, 2048 is a gentle homage to Orwell. Back to Bitcoin. We can date back the very first heartbeat of the new world when the first block was inserted in the public ledger that is the substrate to Bitcoin. The Genesis block has a timestamp on the 3rd of January 2009, 6:15, 5 seconds, Greenwich time. This Genesis block is the 0 block, is the first block ever. It doesn't reference any subsequent block, and it was added using ad hoc code. So it was a sort of initialization, like God that pushes a button and creates the new world. This was 2009. In 2017, Bitcoin is still there, and it was over 5,000 euros in September. Yesterday, it was 5,471.91 euros. In action, why again Bitcoin is relevant, has been relevant in the 30 years from 17 to 48? Because of blockchain. Blockchain is the database, is the event store, sort of, that Bitcoin runs on. And if we think about blockchain as an event store, underlying event store, on top of it, in 30 years, we have learned how to build more and more and more applications. Today, or 30 years ago, depending on which time you are set on, in 2017, Bitcoin is the primary application that runs its own. Blockchain is the first application that has run on this concept of a general universal event store, and cryptocurrencies, not just Bitcoin, which has been the first one, many other cryptocurrencies run on the same principle, on the same concept of an event store. So in general, it's so easy to imagine, and it's probably slated for next year, for 18, 19, the next couple of years, the area of payments, digital payments, the area of digital contracts, the area of digital identity and management thereof are the obvious next steps in the evolution of the orange blocks, virtually everything else we can add on top of this blockchain-style event store. And virtually everything else is what we will see, the shape it takes in the next decades. Now, what is the mechanics behind blockchain? There is a transaction. Transaction in the general term, so it's a transaction, it's an action that involves parties and data, whatever kind of data. So the transaction is validated, is passed through a network, a peer-to-peer network. All the red blocks in the picture are essentially nodes of a peer-to-peer network, and computers, users known as miners, are there essentially to concurrently solve a cryptographic challenge. And the moment in which all of them have validated, have reached the same result, that transaction and whatever data comes with that transaction is considered to be absolutely fully trusted, true, and it becomes a piece of information that can be added to the chain of events. And in fact, validation creates a new block that is added to the chain. Finally, the device, whatever device that started the transaction, receives a notification, success or failure. Any failure in the miners, so if any of the check marks there has disappeared at some point during the operation, no success will result, or whether or not the final green check mark appears or not depends on the logic that you have in the various validation nodes. So it could even be that certain applications consider trustable a result that has the 80%, 90% of approval. In some other cases, you need to have 100% of the miners to be successful in resolving the cryptographic mathematical challenge for the operation to be considered fully trusted. But now the interesting thing is that blockchain is the sequence of blocks, because every block represents something that has happened. And nicely enough, this is the same definition we hear today when we approach articles, books, frameworks that mention event sourcing. An event in software is the memory, the digital memory of something that has happened. An event store is an append-only database. You can only add on things. You can never edit or update or remove or change in any way, alter in any way the sequence of events. Your entire application will be broken, which poses a number of challenges in terms of clustering, in terms of backups, in terms of preservation of the data. So the blockchain likely will be, the memory of the universe. Blockchain is like a Google Docs, essentially. It's a common block of memory with many concurrently acting actors. Unlike databases, we know today, in 2017, there is no sharing. There is no operations that needs to be duplicated. There is, the database is never shared between users, but it's duplicated, even thousands of times, across a network of computers, and it's constantly updated, all the nodes in the network, and whatever information is stored there is public and easily verifiable, but not changeable. So, if you project this vision, okay, you have to have, in a way, the mindset of the fiction writer, but if you project this to a new world, you figure out that the blockchain has the potential to be an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything of value. The quote is from one of the founders of the major blockchain research institute. So we have the potential, and we discovered this potential in the 30 years in between 17 and 48 to find a global, universal mechanism, the blockchain, which acts as an incorruptible memory. So a place where everything is recorded, is logged as an event, as a software event, everything is logged there in a way that cannot be altered unless the foundation of the modern mathematics is completely revolutionized. There are a few concepts related to that. Concepts of 17, like event sourcing, single point of truth, audit log, big data. In 48, event sourcing essentially is the same. It's about keeping track of events. Today, in 17, we consider event sourcing in the realm of a single application. In 48, it's in a single community, because it's so widespread to cover aspects of life. The single point of truth, which is the definition that today we use for an event store within the context of a software system, will just become a universal point of truth. Imagine a place where whatever we do is tracked. An audit log, just public, and big data will become everyday, business as usual, every day, part of everyday life. Imagine the world, a world in which a transaction is essentially an action. Every action is a transaction. A transaction from the dictionary is an exchange or transfer of goods, services, or maybe funds. But generalizing, it can be taken as a communicative action or activity involving two parties or things that reciprocally affect or influence each other. So the concept we have in mind today for what is a transaction, even in abstract terms, abstracted even further to become actually the memory of an action. Exchange or transfer of goods, services, or funds is a good definition, abstract definition for a transaction today in the world of the internet. And the same concept is expanded, taken to the next level of abstraction, and becomes a communicative action or activity involving two parties or things reciprocally affecting or influencing each other is the definition in the new, let's say that, in the new internet based on blockchain. So internet and blockchains are on the same plate, and the same scale, and they have weights that changes. Internet, 20 years ago, in the late 90s, starting at that point, introduced changes in our life that if we look back, seems ages ago. In the 90s, there was no digital storage. There was no photography, no digital photography. When I started this career, you wrote the first web page in 92. But in 94, there were no JPEG format, no JPEG files. You only had bitmaps, maybe TGA formats, and that was that. There was no lossless, there were only lossless compression formats. My company of the time bought an extremely expensive license from a US company to use a fractal algorithm to compress images. And actually, my company built, in 94, something that today we call at least Flickr. But it was way too early, and the company bankrupted. E-commerce and booking, late 90s. We were all dreaming of being able one day to write an email or connect to a website and book a flight instead of calling the agent over the phone and discussing and going through many phone calls. Not to mention speak recognition, which was only in the science fiction movies, Star Trek. It's reality. Mobile computing, geospatiality, social media, instant messaging, and of course the fridge that sends you an email. Look, we have shortage of eggs and milk, please provide. All of those things are based on what we call today big data, but in the future, we have even bigger data. And we can expect a world made of social transactions, digital ubiquity. You can be in different places. Not you, but digitally you. Your digital soul will implement, finally, ubiquitous. Universal identity. Change your profile. Your family, you, or in your professional you, your fake you. Well, we already experimented maybe with Second Life years ago. It's now disappeared, but it will be back in a wider and larger format. Polyglot communication. In much the same way, in the late 90s, the big change that the .NET platform brought was that it made possible to write applications regardless of the language. I mean, except Dylan, everybody else probably will have troubles. I mean, if I judge from the average age of the attendees to this conference, which I've been told is 28, you guys cannot remember how, hard it was in the 90s to have to use Visual Basic to connect it to run a stupid select star from customers and using everything else in C++ or C# or C. I mean, you had to go through ODBC or OLEDB if you were using C++ to run a stupid select star from customers. In much the same way .NET solved the problem of programming languages, why not? Blockchain or applications of blockchain could solve in the next 30 years the problem of human communication. Algorithmic work. This is an extremely tricky point. We mention machine learning these days, artificial intelligence, but now it's a very, very, very simple form of it. It's essentially nothing more than brute force stupid algorithms. Still working, but there is a tremendous potential, mathematical potential, of increase in what algorithms can do. So algorithms are the real future of software. And body transactions, actions and transactions. Whatever you do can be tracked. Live monitoring. So big data even bigger and adding more and more digital functions to our life. This is essentially the forecast, a reasonable forecast from the world of internet we have today, we know today, and the blockchain world we may know 30 years from now, featured in the DotNext 48 edition. So it's a matter of balance. Knowledge, life, the more knowledge, the less life, the more life, the less knowledge. It's a scale. In a world like that, and now it's the fiction writer in me that emerges again, every business transaction in this world, the world of the future, again, I love Orwell, every business transaction could be logged. Every buck you make, every buck you pay, every good you buy, every good you trash, every place you go, every face you meet, every word you say, every chart you type, every time you're sick, every beer you drink, every bite you eat, every step you take, every move you make. Come on. Every woe you break, every smile you fake, every claim you stake, I'll be watching you. The police, well, the police, the rock band, but again, in Orwell, there is the psychopolis that is constantly watching at you. Monitoring. I'll be watching you, so I'll be monitoring you. Your health, your social activity, your behavior. And, well, why not? We could apply to those areas of investigation common patterns, debugging, profiling, refactoring on you. There are some non-trivial consequences. Your life as a database could be fun. Someone can run a SQL query on you to determine what is wrong with your health. Maybe a company can run an unit on you before you are hired, or someone can even on you if your performance, whatever performance, is poor. And now, this is serious. If in 2048 your performance, whatever performance, is poor, it means that one of those guys can be called to fix it. Maybe Federico Lois can be called, or Raffaele Rialdi. Or maybe, and this is the worst, Martin Baglio. Not happy? Dylan can run another talk, living a self-aware life, automatic happiness monitoring. It's not finished yet. If you're still not happy, Mark Seaman can run from happiness injection to happiness rejection. So there are essentially no limits in the future. Is this still life? Well, there are good parts. The good part of it is that computers would take over the most boring tasks of our life. They could drive a car for you, or they can book a flight for you even better than today. Today, we use computers to book flights, but it's us. In the future, computers can just drive cars or book flights, or they can buy things for us, or can they pay bills for us. They can fix broken toilets for us, or bringing the trash out for us, can receive spam for us. They can do everything for us. They can do everything for you. Having sex for you? Hopefully not. Regular applications for you? Yes, please. I wish this. I'm particularly looking for, but again, beyond jokes, many speakers whose talks I attended yesterday and today, Dmitry Sajnikov, Raffaele Rialdi, and other speakers, mentioned that they envision in the future that the future of artificial intelligence is, for the most part, Dylan, of course, is another one who said exactly that, sorry. They said, and I couldn't agree more, that the future of artificial intelligence is having machines writing software, at least the boring part of software for us. Angular applications is only the most illustrious example. Is this still life? The moment we embrace blockchain, so all those possible extreme consequences, in some way can be reported back to the adoption of a modeling model based on blockchain and the event store. It means that everything will be fast and absolutely deterministic. No weights, no secrets, no jealousy, no crime. Well, every crime is there. We don't need Hercule Poirot or detectives in fiction stories to find the culprit. Everything is written there. We only have to run select from a database, okay, to find every crime. And of course, no privacy. And that is my dream. That's my dream because for me, it's all about love. I hate security, safety, those words, privacy. Oh, I'm so open. So no privacy. Well, in 2048, and again, this is another, let me do that, homage I want to pay to George Orwell and his wonderful 1984 book. Also, in that book, only dreams were private. So in 2048, only dreams will be private. Maybe. Because in .NET 2048, we still have a guy presenting, debugging, and profiling erotic dreams in Linux. Who's this guy? Sasha. No more erotic dreams, not in Linux. On Windows, it's much better. Linux is more open, but even Windows is opening up. Computers will overtake humans with artificial intelligence within the next century. When that happens, we need to make sure that computers have goals aligned with ours. I was not a speaker at this conference, not even Dimitri, not even Dylan, not even me who said that. The author of this quote is Stephen Hawking. Only 2 years ago. And Stephen Hawking, extremely popular scientist, genius, director of research at the Center for Theoretical Cosmology at Cambridge.
We are the Borg. Lower your shields and surrender your ships. We will add your biological and technological distinctiveness to our own. Your culture will adapt to service us. Resistance is futile.
Resistance is futile. Future is approaching. In 2017, data, what we call big data, counts more, I would say much more, than algorithms. Machine learning these days relies on, let's say that, brute force algorithms. Machine learning today builds on top of an obsolete statistics theory. It's the Bayesian theory, which was devised over a century ago. And a new field in full development is quantum statistics. So we have a full new engine to put in production to improve machine learning and artificial intelligence. Today, big data, what we call big data, can get faster than algorithms today to get the results we expect. And by the way, big data, or a variation of that, was the trick that allowed Alan Turing to crack the Enigma machine during Second World War. Alan Turing is the guy, is the brains behind what we call today a computer. And Alan Turing was the guy who drove the effort in Bletchley Park, the UK, he led the team to fight against the encryption used by the Enigma machine. And actually, they succeeded. They used the brute force machine. They built a machine to do brute force checks. But they won the day they discovered recurrences. Stupid. Wrong because unsafe. Recurrence in the keys being used to encrypt messages. So big data helped Turing to crack the enigma and win the Second World War. Quantum computing is a completely new field and will mark the comeback of algorithms. Now, quantum computing is not going to change, at least for what we know today, and I'm talking about the life on the planet, not just the knowledge of humans. Quantum computing is still a finite, deterministic thing. We just increase the power, and the computing model is revolutionized, but it's still a finite model for calculating things. So problems we know today that we qualify and categorize today as NP complete, NP hard, so unsolvable problems, problems that can only be solved using algorithms whose computational effort is measured by an exponential function in the size of the input. So those problems will still be NP complete, but they will become, because of the new computing model, treatable. Or at least, if today we can treat and implement solutions to NP complete problems with the size of the input that is small enough, that size will become much larger in the future because of quantum computing. And you know what it means? We break cryptography. Because everything we do today that has to be a secret is enforced by the lovely relationship between two prime numbers long enough, large enough, big enough. And big enough is prime numbers of thousands, digits. With quantum, so even today, with the brute force algorithms we use today, we are going to treat NP complete problems to an N size of the input that is set thousands of digits long. And in fact, cryptography is a continual catch me if you can in history kind of game. And the next step is the introduction of quantum algorithms, quantum statistics in the formulation of new algorithms. Look, this is not, as far as cryptography is concerned, this is not something that happens now. There is a wonderful book, David Singh, History of Cryptography, published in '96. And the final chapter of over 20 years ago mentions quantum statistics as the new frontier 20 years ago from now, as far as cryptography is concerned. In 2048, it's an easy forecast at this point. Algorithms will count more, much more than data, and to a large extent, this is my opinion, my forecast, much more than even technology. It's all about algorithms. Think about doctors. I have a son. My son is 19 years old and is a first year university. So a few months ago, we went through as a family, through the usual talk to friends. Oh, what your son is going to do? What your son is going to do? Mathematics, literature, philosophy, engineering, this, that. When my son met a friend, what are you going to do? I want to be a doctor. You want to be unemployed in the future? In the near future? No, I mean, a doctor will never be unemployed. I mean, we won't have doctors, he said, in 20 years because of artificial intelligence. And by the way, and I said, look, son, I'm your father, okay? Talk to me. Who said that? And then he said, I had a chance to talk in the final days of high school, we talked to a couple of researchers from one of the cancer fighting centers, institutes of research in Rome, and he said to us that all his team does is writing algorithms to process big data. So that's the way to fight cancer. Today, imagine what we can do 30 years from now when DotNext 2048 will be up and running. Resistance is futile. You will be garbage collected. Thank you. And see you at DotNext 2048. We will be here from the Red Square.